4.1, Unit 4 is going to be on a bunch of different theorems about triangles. And Chapter 3, we were proving things that were congruent. Now, instead of us talking about how two triangles are congruent to each other or doing proofs, what we're going to do is we're going to use or figure out some properties about triangles. The first one is going to be dealing with this thing called a midsegment. It was the thing that you were trying in the 4.0 worksheet. When I gave that to you, you were supposed to figure this stuff out about a midsegment. If you did, great. This is a summary of what you should have figured out. If not, these are the facts that you need to know about a midsegment. A midsegment is a segment that goes from one midpoint to another in a triangle. Meaning, if I look at point D in this picture, if I have a midpoint and another midpoint, I know these are midpoints because this piece here is congruent to this piece there. And this piece here is congruent to this piece there. So it's going from a midpoint to another midpoint. That means that DE is a midsegment of this triangle. Midsegments have two properties that we're going to use a lot. The first property is that it is parallel to one side of the triangle. If it's parallel, it means that the slope of this is going to be the exact same slope as this one. That's what you learned on that worksheet. The second thing was that this midsegment was exactly half the length of the side that it was parallel to, meaning that this was half of this length that it was parallel to. Sometimes we will be dealing with problems with that are half, and sometimes it's just a little easier to double it. I sometimes double the midsegment to make it equal to the longer side that it is parallel to. Let me show you how I remember that, first and foremost. Here's this picture. If I were to take this midsegment and I were to actually cut it down with a pair of scissors just like this in my brain, and then what I would do is take this piece and rotate it about this point until DC lined up exactly with DA, this is what you would get. You would get like this. Do you remember how we said that this was parallel to this? Well, that would mean that if I flip this until it hit, then that's still going to be parallel. And what you would have is this shape. And this shape, since this is a 1 and this is a 1, and this would be the 2 would end up being right here, you would have the double and the double the same. And you would have the single, and then you'd have this, and then you would have that. And what shape it would be a parallelogram. The opposite sides of the parallelogram are the same. If you look at this DE, you have 1, and then you went over until it landed right there. So I have a DE and another DE. So 2 of them would then be equal to the other side. That's kind of how I remember it. And that's a property we're going to use a lot. Erase all that. The last thing that I have up here talks about the corresponding angles. The corresponding angles are congruent. And if you don't remember which one corresponding angles are, this is something you learned last year in either Advanced Math 8 or in Math 1. Corresponding angles were the angles that matched, that were on the same side of the transversal, but they skipped a space. They were not next to each other. They are congruent. They actually make what I told my regular Math 2 kids is it looks like the letter F. Sometimes the letter F looks like this, upside down, but the angles on the inside of the F are always going to be congruent to each other. And that's going to come into play with problems like this as well, because they're parallel to each other, parallel. And you're going to see maybe the letter F this way. I hope that makes sense to you. So let's do a couple of examples, and then we'll work our way down to some problems out of the book. The first thing that I see is, let's look at this example, AD and DC. How are these two things related to each other? They are congruent. They have to be. If this is a midsegment, this is at a midpoint. Those two pieces have to be congruent to each other. AB is blank with DE. AB and DE. There's a couple of things that could fit in here. The first thing that could fit is that, what is their relationship? They are parallel, is the first thing that I can think of. And then I can think about their sizes. AB is equal to double, 2 times DE. I could also put that in there as well. They both would work. Lastly, if DE was 16x, then AB has to be 32x. Fairly simple, and that's pretty much how the basics are for this section. This section is going to be very easy for a lot of you. So I have 4 problems picked out for you. If you would like to do these in your textbook, you can. I have chosen number 3, number 10, number 17, and number 26. I'm going to start with 3 because the number one way they're going to try to trick you is they're going to try to get you to look at that and just go, oh, I know that I can just plug in a 9 or something. Well, it's not 9. Don't think that these things are equal to each other. This is a mid-segment. Mid-segments are half. So if I were you, I would take the mid-segment, and then what I would do is I would double it to equal the side it is parallel to. When you're dealing with mid-segments, double the mid-segment to equal the other side, the parallel side. If I double 5x, that makes it 10x. And then you can divide by 10. I can divide or reduce by the number 5 into both. And I would accept either 9/2 or 4.5. Either one is correct. But it's fairly simple. Number 10. If 2 non-collinear segments in the coordinate plane have the slope of 3, what can you conclude? What this means is that they're not on the same line. Something over here has a slope of 3, a rise of 3 and over 1. And then something over here has a rise of 3 and over 1. What do I know about 2 lines or 2 segments that aren't collinear and they both have a slope of 3? They are what? Say the word out loud. Parallel. Or you can use the symbol. They look like L's, but they're a little bit bigger than that. They're tall. 2 vertical lines. Number 17. X is the midpoint of UV, segment UV. If it's the midpoint, what that means is this is congruent to that. Without this statement and without this statement, y is the midpoint of UW, then you could not do the problem. You would not know enough information about it at all. So we go to this and we'd say, oh, that's a midpoint. That must make this a mid-segment. Now that we know that it's a mid-segment, let's answer the problem. If the measure of angle UXY is 60 degrees, UXY. They use 3 letters because you can't just say angle X. Let me emphasize this because I just graded your test this weekend. For those of you who think you can just say angle X, well, is this angle X or is this angle X or is that angle X? Whenever there are multiple angles with an angle, you have to use 3 letters for the angle. I say that because I graded some tests and some people messed up on some small stuff like that. Can you use angle V only 1 letter for angle V? Yes, it's the only angle V that there is. But if there's multiple angle X's possible answers, you have to use 3 letters. Otherwise, it's not correct. And it has to go side, vertex, side. U, X, Y. is 60 degrees. Find the measure of angle V. They're asking about this angle down here. What are we going to use? Mid-segments are parallel to this one. So angle V has to be how many degrees? If you know it, say it out loud.
60.
It's 60 degrees. Because of what type of angle? Say that out loud. No. Corresponding angles. Thank you. Alternate interior has nothing to do with these ones. These ones are based off of the corresponding angles, parallel lines, and then if you're looking for that shape of an F, it's right there. Last example, 26. I like 26 because it deals with mid-segments, and then it doesn't even ask the distance of the side that it is parallel to. It asks for the left side. What is x? And I saw this and I said, okay, midpoint. Yes, this is a midpoint. These are the same, so this is a midpoint. That must mean that 5 is a mid-segment. That means I know what the bottom is going to be. The bottom has to be 10. But it's not necessarily, when I look over, I go, okay, how on earth is this left side, how am I going to figure that out? Then I realize something. Something jumps out at me, this 60-degree angle. You see it? Well, this is an isosceles. It is. That's 60. That has to be 60. You could also say the corresponding angles are 60 and 60. And then you could even go, oh, now that I know that these sides are the same, and that's 60, that's 60, that's 60, I know the top has to be 60 because it is equilateral, which means 10, 10, x has to be equal to 10 as well, just in case you didn't see it. Yes, sir?
How do we know that the 60 above, and for the 60 for the smaller triangle, how do we know that those angles are corresponding?
These two? Remember how I told you this is a midpoint and this is another midpoint? It's a mid-segment. It's parallel, so the corresponding angles have to be congruent if they're parallel. I know here and here have to be 60.
So if we were writing a proof, would we write like definition of mid-segment?
The definition of a well, that's a property about a mid-segment. Because we're using a property, we would name the property. The property is that mid-segments are parallel. Just like vertical angles. You don't say definition of vertical angles. You would say vertical angles are congruent. That's a reason why you could say two vertical angles are congruent. That's a property of vertical angles, not its definition. Just so you know. It's good for you guys to know that. Let's stop your notes right there.